Okay, so the next question, number 5. Again, we have the same model. I just keep repeating this part in each and every question. Um, and the question is saying, based on the regression results, which of the following is true? And if you notice that we have basically a question about beauty variable, English speaker, English speaker. Okay, so these are the two variables that we need to focus on. And then when you go here, the beauty variable is positive, meaning that the better the physical appearance of the professor, this increases the course evaluation by 0.16, 561 points, right? And this, so you're looking at beauty 0.16, it doesn't seem to be the answer, right? Because these two numbers are not there. And then non-native speaker, so you go to non-native speaker, it's negative, so the answer has to be decrease, right? There is 1 unit increase in this variable would decrease this variable, so it's an opposite relationship, right? It's a negative relationship. This one is saying if the professor is a non-native English speaker, this decreases the course evaluation by about 0.24 points. So you need to find one of these numbers, and it's right here, which is answer D. The next question, again the same model, and it's based on the statistical significance using the p-value. And the p-value of the coefficients of the constant and the variables in the order above respectively are. So you need to look at the p-value, which is right here, and you need to find this order, right, these numbers, and it's kind of a straightforward answer, and you find them here. Okay, the next one, and just notice that the constant here in the order I have above, right, is the first one. In the output, the constant appears the last. So you need to have 0 at the beginning because this is the order that I have above here in the question. I have a constant before all the variables, and that's why we have 0 at the first here. The next question, number 7, this one is based on the regression model. The standard error of the regression is approximately equal to. This one is a more challenging question because the standard error of the regression is not in the output. Like it's not directly in the output, you need to compute it. The standard error of the regression used the sum of the squared residual, which is this one, sum of the squared residual, and divided it by the sample size adjusted for degrees of freedom, and then you take the square root of all of that. So you need to take the square root of this number, right, of the SSR, divided by the sample size adjusted for degrees of freedom. Okay, so I gave you more information here. So question number 7, this is the equation of the SER. It's the square root of SSR divided by sample size minus the number of parameters. Number of parameters 1, 2, 3, 4, 5, 6. So k is equal to 6 minus 1 for the intercept, for the constant. Okay, and then you compute this one and you basically will get the answer. Okay, and also in the feedback, like when you click on feedback, you should also be able to get the like the detailed computation. So when you click on feedback, you should be able to see the number. Okay, so you will be able to get as B is the correct answer. Question number 8, based on the regression model, the 90% confidence interval for the 1 credit coefficient is equal to. Again, this question is a bit challenging because, as you know, what we have here is a 95%. Okay, so you need to compute for the 90%. You know that in order to compute a 90%, then you need to have different critical values. So you need to have the coefficient, right? Then plus or minus. The critical value for the 10% is going to be 1.645 multiplied times the standard error of the coefficient. And this is exactly the formula for the confidence interval. Okay, and then telling you here, again, this is question 8. Note that Stata computes the 95 confidence interval, but the question is asking you to compute the 90%. Given the regression results, you compute it using the coefficient and its standard error and the critical value of the standard normal table. So the upper bound would be equal to, this is the coefficient, multiplied times the standard error of the coefficient, multiplied times the critical value, 1.64. You can add 645, which is, that's fine. You can add the whole thing, which is the critical value, and the lower bound would be this one, okay? And okay, and then you'll get this interval. Okay, so you'll get the interval, which is found right here. This one is found right here in number B. Okay, question 9, 10, and 11, they are all about the statistical significance of the coefficients. So based on the p-value of the results, the coefficients of the constant and the variables imply that. So you can just look here. This is the p-value. As you know, the null hypothesis is saying that the coefficient on beauty is equal to 0. And the alternative is saying that the coefficient of beauty is not equal to 0. So it's a two-sided test. And this is the default in Stata. And the same thing for this coefficient, for this coefficient. So for each of these coefficients, we have its own null hypothesis of being equal to 0 or not equal to 0. So a p-value of 0 basically saying that there is a very small probability that the null is correct. There is a very small probability that this coefficient on beauty is equal to 0. There is a very high probability. When I say high and low, I'm comparing it with the default of 5%. This one exceeds, of course, the 5%. If you multiply this times 100, it's going to be 83.5% exceeds the 5%. There is a very high probability that this coefficient is equal to 0, which means it is statistically insignificant. There is a small probability that this coefficient is equal to 0, so this coefficient is statistically significant. Statistically significant. The same thing here, this coefficient is less than 5%, or it's, I mean, like this p-value is less than 5%. It's basically 2.9%. There is a small probability that minority is statistically insignificant, or there is a small probability that minority coefficient is equal to 0 under the null. There is a very small probability for the null again. There is a very small probability for the null on the constant. So the only coefficient that is statistically insignificant is the coefficient on intro. This one is telling us there is a high probability that this coefficient will be equal to 0. In other words, this coefficient is statistically insignificant. So you try to find this answer here, okay? And then based on answer number C, at the 5% level of significance, we fail to reject the null hypothesis on the coefficient of intro only. Okay, so we fail to reject, meaning that we accept that the coefficient of intro is statistically insignificant. Okay, so we have a very high probability that the null is correct. So we basically have to accept it, right? Or statistically we say fail to reject it instead of saying accept it. So you say fail to reject it, because there could be other options available. So when you accept means that this is the best, but this is not the best. We just fail to reject it. When you go to the next, and you have more information here. When you go to the next question, the p-value results of the coefficient on the constant and the variables imply that. If I said that I fail to reject the intro, then it has to be the case that at the 5%, all coefficients are statistically significant with the exception of the intro coefficient. And this is what I just said. And then question number 11. the p-value of the coefficient of the constant and the variables imply that. So 5% significance level, all coefficients are statistically significant with the exception of the intro coefficient. Okay, so that's it for this practice. And once you're done, you just submit for grading. Again, it's non-graded, but this is just for your own practice. Let me know on the discussion board if you have questions on this.